have another session in next Saturday. So with us, we have Pavan Adha, who has been handling this particular session. And today's session will be in two parts. Initial 15 to 20 minutes, we will take some questions based on the problems you occur. I mean, the technical issues you have faced in the last part during implementation in the last week sessions. And after that, Pavan will go through the agenda, and then at the end we will bind up with some questions answer session and some thoughts for next sessions. So Pavan, over to you and your life.
Yep, thank you, Ravi. Thank you so much. Okay, all right. Good morning, guys. So let's take a questions answer actually. So let's discuss on the questions you faced during the last session. I mean, after the last session, what are the exercise you have done? So if anyone have any question, you can just ask me. We'll have a discussion on that. Any kind of general question is also fine. It's not something it's related to that particular exercise, but on the hyperledger fabric, whatever we covered so far on the core concept, we can discuss now. Any question, you can unmute yourself and you can ask. Guys, do you okay, can the session is already getting recorded, so Ravi will share all the links, a relevant link actually with you guys.
Okay, so for the recording part, you just go to the Hyperledger India chapter LinkedIn Student Society LinkedIn page, and there you will on the event side, event tab, you will find the event located, and below that you have the recordings as well. And anyways, I will also share I uploaded the recordings on the wiki page, and I will share that wiki page link over here.
Anyone have any question? Otherwise, we can move forward actually. Okay. Okay, on the number of organization, again, see, so initially when we decide to create any kind of network, it's very important to understand like what kind of architecture suits for your use case. In supply chain, there are thousands of suppliers and all. We cannot host, I mean, we can, but still it's not relevant to host one organization for each and every supplier, right? And even they won't be able to bear the cost as well because the cost of the 1000 organization will be very huge. So in that case, it's manufacturers or maybe someone who is main entity in that network is responsible for handling their transactions. So maybe they can create some kind of logical segregation at the API layer itself, and they can put data onto the uh, blockchain. That is one case actually. And how to improve the performance. Okay, so Fabric is getting matured over the time, and now we are getting very good transactions per second, but still people have some use cases where they require very much high TPS, I would say. So in that case, we have to fine tune our network. That is the first thing. Fine tuning, it means what exactly? You have to uh, you have to make certain changes in our applications, like endorsement policies and all, or maybe block size and block time, so that we can achieve highest TPS in our network. That is second thing. You can improve the performance of your network. Next one, like resource configuration is always one of the thing where you can get higher TPS, but up to certain extent we can increase the TPS. Sorry, this resource configuration, right? Beyond that we can't. So we have to find that actually the benchmark of that particular our network so that we can get best performance out of it. Okay, fine tuning first thing, and bumping up your resource configuration second. Another one thing, like if you have a lot of transactions, and you can use some kind of queuing mechanism as well, like if your network is not able to handle that, there may be 10,000 transactions per second or something like that. You have to you maybe can choose messaging queue actually. Just put into the message queue and just process the transaction, whatever the uh, limit your network has. Like your network can process 1,000 transactions per second, but you are getting 3,000, 4,000. Still you can do it, but you do through the queuing actually. That is one thing.
Excuse me, how this queuing mechanism is implemented? Is it by storing it in some database?
Yes. Yeah. Yeah, initially like from client to the API side. So maybe RabbitMQ or something you can use in between. But it's again totally depends on the user's use case and like what kind of requirement you have. It totally depends on that. You have to architect that actually. Okay, writing the smart contract. Yeah, definitely. Writing the smart contract also can impact your performance. So smart contract, we can embed our business logic. If it's taking much time to just process, right? It's doing a lot of operations here and there. So probably that could create a that would create additional latency actually, right? So we have to make sure we are doing only necessary operations at the smart contract. Any other question? Okay, I'm sharing my screen now. We can go ahead again. Okay, guys, you can see my screen.
Yes,
Uh,
it's visible.
Okay, all right, perfect. Okay, so last time, okay, let me just open the resource agenda actually. Okay, so initially we have gone through the introduction. After that, we have gone through the basic concept of the hyperledger fabric. Even we managed to create this hyperledger fabric network as well. Okay, and we followed certain step to just create the network. We invoke some of the transactions, just making sure our network is already up and running and it's working as expected. So those are all the operations we have done in the last session itself. First one, basic hyperledger fabric core concept. Second one, creation of the server actually, not server, so creation of the blockchain network. Now in this session, we are going to cover blockchain explorer integration and API related. Blockchain explorer integration is just a straightforward. It will not take much time because I have already doc containerized application, so should not be a problem. This most important part of Hyperledger Fabric network is the API because that is the entry point for your network. So how we can write the API, how we can invoke the transaction even from any kind of client. It could be UI or it could be a uh, Postman or it could be anything third party application as well. So that part we will be covering in today's sessions. And if time permits, we'll have a brief on the front end as well. But probably in the next session, we are going to cover the front end and creation of the contracts, how to approve the contracts, how to get it, how to get the history. That some of the APIs I have managed to do it. So let's start with the blockchain explorer part. Okay, this is the fourth and I mean this in this session we are going to cover fourth and fifth part. Okay, last time we had a discussion like we will go through the prerequisite, right? So prerequisite is nothing but just additional requirement of some this framework or maybe some packages on our machine. So this is the first thing. If you did, I mean, I did not get any questions on this part, so I'm sure you might have already installed all these things on your machine. On local, generally, most of the people will have by default. But still, if you wanted to make some new deployment on the new virtual machines, then in that case, you can just follow this. This is just the basic things. You have to run the commands one by one, and you will be able to install all the necessary things here. So what we require actually, so we have different things, right? Operating system, you can use anyone. MacBook is also fine. Linux is also fine. I just added like this Ubuntu, which I used actually during that time. So you can use any later than 16 version, I think. That's recommended. For Windows also you can do it, but there are some additional steps for the Windows. So we have to check on the official documentation what additional steps we need to cover it. Okay. Next, we require Git. By default, it comes in the Ubuntu 22. Docker, we require Docker Compose, we require. Go version is optional. If you have your chain code in the Go version, so in that case only you require this. Otherwise, Go is not required actually, because we for this use case we have written our smart contract in the Node.js actually. So Node version is required, npm and Python. Okay, these are the different steps. Just follow this, and you will be able to uh, you will be able to create a network using this prerequisite actually. Okay, so I'm just going through this one. I have already done on my machine, on my local it's already there. Even on the virtual machine is also, we can just follow the same thing and you will be able to do it. You can verify the version using this different kind of commands. Okay, one more thing. Once we are done with the prerequisite installation, we require this Hyperledger Fabric sample, binary, and the Docker image. Okay, so for that purpose, uh, we have to run this call, and this is in the official documentation also it's mentioned the same. So it will download one file and it will just start execution. Okay, this one, and it will download all the necessary things. Here we have provided specific version of the Hyperledger Fabric. I want to download this 2.5.5 with the certificate authority version 1.5.7. So it will just download all the necessary stuff. Why we are downloading that? Fabric sample and the fabric sample and these images and all. So for Hyperledger Fabric, we require images, right? This peer image is required, order image is required, CowZip is required. So these things will get covered here, and it will download all of the things. There are some binaries actually. In Fabric sample we have, and in the Fabric sample, when we download it, all the binary will get downloaded. Where we are using that binary, let me just show you. Okay, so these binaries are getting used. So we have used the scripts, right? So inside the script, create channel, OSN admin. This is the binary actually. I already have Fabric sample downloaded on my local, and there all these files are there. Like, let me just show you probably. Okay, you can see here, right? Config txgen, config txletter, cryptogen, discover, fabric CA client, fabric CA server, ledger utils, orderer, OSN admin, peer. Okay, I'm just considering, I'm just considering we have downloaded fabric samples for the fabric 2.5 version. So you may see, like, if you're using 2.2 or something, you may see some additional, or maybe this OSN admin is introduced in 2.3, I think. So there is a possibility you may seem little different in case of other version, but we are dealing with the 2.5, so you will be able to see all these binaries, and this binary have all the functionality, so we are able to run these things actually, right? So once fabric samples you have downloaded, you have to export this path and provide it, so that on Windows generally what happens when we install any kind of executable, it will just get added in some specific folder. But in the Ubuntu, if you are downloading this kind of binaries anywhere, you have to specify the path in the bash rc file, or profile on the Mac actually. So I just exported this path in my bash rc file, and if I'm running this orderer, or maybe, okay, I will be able to run it, right? This one here, we will have this kind of different commands, because I added this path in my bash rc file, and that's why I'm able to execute these binaries from anywhere and from the terminal itself. Like in this script, we are using the same thing. Okay, every binary have their own purpose actually. We'll discuss it later maybe, but yeah, for the basic understanding, orderer peer we are using already. OSN admin we are already using. Fabric CA client is also using, but from the API we will be utilizing it. Fabric CA server is the Fabric CA server. Cryptogen, I think previously we used to use. Right now, I think we're not using. Config txletter and config txgen. These are getting used in creation of the artifact. Let me show you. Create artifact.sh. Config txgen, right? This is the tool where we are just assembling these all the policies and creating the channel configuration block. Config txletter is used for manipulating this protobuf into the JSON and JSON into protobuf, something like that. Okay, so these are the binary. Any question on the binary, you can ask me, binary or something on the prerequisite. Okay, all right. Next part is blockchain explorer. Okay, so right now my network is already up and running as we have already in last time, right? Let me just open it. Okay, for network creation, we just followed the same steps. First is the certificate authority creation. After the certificate creation, artifacts creation, so running all the services, create channel and deploy chain code. Okay, these are the steps we have to follow. Even though you have stopped your networks and all, certificate creation would not require because we already have the certificate, and that's why artifacts creation is also dependent on the certificate. If we have same certificate, artifact creation is also not required if you have done already one time. You can just run the certificate authority first. After that, create our all the peer orderer CouchDB server and create channel deploy chain code. These are the only steps we might require. I have already done it. So you can see Docker PS. So you will be able to see this all the network. Sorry, these all the things are already up and running. Okay, now after that, blockchain explorer. Let me just show you the dedicated folder is there. Okay, for the blockchain explorer, here we have. All right. Okay, just deleting this. Okay, in the blockchain explorer folder, we have one dedicated Docker Compose file. So in the Docker Compose file, we are specifying two things. First one is the Explorer database. See, this blockchain explorer is just nothing but the client. It's not something different. Here, this blockchain explorer will just fetch data from the blockchain network and put into this PostgreSQL database. And this is the service which will do actually fetching the data from the blockchain network. These are the two different services: explorer.mynetwork.com, explorerdb.mynetwork.com. So we have to provide some credentials and all. I'm creating this service right now, but it's in case if you already have the PostgreSQL database and all, you can just you utilize that as well. That should be fine. We have to we have to provide here username and the password explorermynetwork.com. Okay, these are the two different services we have, but this require actually three things. First one is the configuration.json file where we have that here. Inside the configure.json, which connection profile we have to use, we have to specify. Here, connection profile, fabric network 2.2. Okay, fabric network.json, I think it's getting used for 2.5. And here we provide the admin public and the private key. So this admin public and the private key we require because we have to fetch data, right? We will set some listeners. I mean, this Explorer does everything. We don't need to worry. But on the behalf of this admin, he will be doing this, setting the listeners, and whenever there is a new transaction or new block get created, the data will get added into this PostgreSQL database as well, which is mentioned here at the top, right? And it will get stored, and we can just visualize the data on the UI. Okay, for that purpose, we require to copy paste that config cryptoconfig.yaml file. Sorry, cryptoconfig folder itself, where we have all the credentials. We require just only one organization. Okay, let me just show you. Okay, this is the folder. I'm just copying it. So inside the Explorer, I'm just pasting it. Okay, and here we have order organization we don't require at all. We require only one organization because this Explorer will be running on the behalf of one of the organization. Organization 1 or organization 2. I'm just doing on the organization 1 base behalf of the organization 1. So what we have here, org1example.com users, because we will be using mainly users only. We require just one public and the private key. We are using admin user, and inside the admin user key store is there. By default, when we create any kind of crypto material, it will have lengthy name actually. So I'm just renaming it to priv_sk. Okay, I already copied actually. I will just delete this. That should be fine. I added in the script itself, just copy this file and rename, make one more file with priv_sk. So this will work without any change actually. Okay. This is the only file required, and signed certificate. These are the two things, because we have mapped these two different files here. Admin private key, which is available /etc data peer organization priv_sk. Either we have to change the name here or here. It's totally up to you. So I made this actually priv_sk. It's little easier, and I just pointed, so we don't require any code change here inside this configuration file. And certificate name is as it is. Okay. Other than this, like this Explorer container is totally different, right? So how they can communicate with these different Hyperledger Fabric network? They need to have in the same network. So by default, our Fabric network is getting created in the artifact_test. So we have to create this container as well in the same network so that they can communicate with each other. So this is very important step. So make sure you have this compose project name equal to artifacts, because blockchain network containers are getting created under artifact_test. Let me just show you that. Docker network test, right? Docker network list actually I'm fetching, and here artifact test. Inspect artifact. Okay, I'm just inspecting, and you can see all the containers are inside this network itself. So we have to make sure our new container Explorer is getting created within the same. So I'm just going inside this. I'm just running a Docker compose off in detach mode. So at the initial phase, it will take some time because it will download this image, required images for the PostgreSQL as well as this Explorer. It may require 1 or 2 minutes, but once we downloaded it, it's a one-time activity. So you will be able to run this maybe within 30 seconds around. So within 30 seconds, we'll be able to see both of the services up and running. And let's see if there any error or something. So we can just always check the log of the container and identify the issue if there is any possible issue. Okay, creating both of the services got created. Okay, this is Explorer dbmynetwork.com and Explorer mynetwork.com. Now what I will do, I will just check the log for this service. Docker logs -f. Okay, we can see we already have some of the blocks, right? If everything is looking green, so it means it's working as expected. If there is an error, you will be able to identify what is wrong. So we'll have some kind of message. So you can just check what exactly the error is. But yeah, it's working as expected. Now our Explorer is running on some certain port. Let me show you here. 8081. Okay, this 8081. So I will be opening in now. Okay, we can see this is the blockchain explorer UX. So where we can visualize our chain of the blocks. The username is explorer admin and the password is explorer admin pw, which is specified in the configuration file here. This one. So this confidential data we should not check in into the GitHub actually. So make sure you guys are doing in the form of env files. Okay. So I'm just signing in. Okay, we can see here total 8 blocks are there. 9 transactions, node 2, one chain code is there. And other than this part, we can see all the peer services in our network. 2 peers are there and 2 orderers are there, right? Sorry, 3 orderers are there, which are running internally on 7050. Blocks per hour, block per minute, transactions per hour, transactions per minute. And here we can see the transaction by organization, org1, org2, or org3, whoever has done it. And finally here number of how blocks are getting created, when it got created, what is the block number, we can see at the bottom. In the network section, again the same information, we will have all the network participant here. In the blocks, we will see all the blocks, how many transactions and all. So within this block we have 2 transactions, right? So we are able to see, and right now the configuration is maximum 10 transactions can be there in the block. So right now we can see on the block number 7 we have two different transactions, this one and this one, and other blocks have the same one transaction per block. Even transactions, if you're going, you will be able to see one by one every transactions. Chain code will have all the transaction under this organization, and finally channel. Even we can, if you have multiple channels in the same organization, you will be able to switch it from here. And we have some other information like setting. You can add users and some theme related changes. Okay. Now what we'll do, we'll just invoke one transactions and we'll be able to see this is getting added here itself directly. Okay, okay, don't worry on this UI and all. I'm just creating one more contract. So we'll cover in the next session this part, how we are creating this UI and all. I'm just adding some random data from the front end itself. Okay, we have just added, right? Okay, 3 seconds ago one block got created, and let's say inside this block. Okay, this is the block hash, and even we can see other information. This block have previous block hash, data block hash, and current block hash. Okay, number of transactions, how many transactions are available inside the block number, when it got created, what is the part of medium, like my channel is the channel where it got created. And if you're going inside that, we'll be able to see actual details of the transactions I was talking about, right? Like first one is the creator, second one is the transaction payload, how many endorsements are there, what is the chain code, every information will have inside the transaction. So, and these are the read set and write set get created at the chain code layer. Like when we're endorsing the transactions, we'll be able to see these things. And here we have actual data. In the right side, we can see for this particular key, we have this JSON formatted data. This is just nothing but the agreement related data, and it's having all the attributes required, like type of contract, name of the contract, first party, second party, documents, and everything. We are putting as a form of value. This is the key and this is the value. And we'll be able to say in this data into the CouchDB as well. Let me show you. Okay, in the CouchDB we'll have other collection, but make sure you are just checking channel name underscore your smart contract name. So in our case, my channel underscore agreement. I think this one or this transaction got created just before. Let me just check the ID. E827. Yeah, this one. So we can see here. We have all the information, all the attributes, contract created by a department, document type, and the document actually, the agreement which we uploaded, it's getting stored on the S3 bucket. It's having the content hash. Where I mean, using this hash, we can just validate whether document got tempered or not. Other information like organization ID, owner, status. I mean, you can just embed anything, whatever you feel it's required. Okay. On the blockchain explorer, anyone have any question? Because this was the just a basic and simple thing. You can just visualize this block. It would be easy to understand or visualize our concepts actually. Any question on the blockchain explorer? Okay, all right. So all right. So I'm going to move to the next section. So API. Okay, this was the blockchain explorer part. We're done with this. So it's a very straightforward. I already containerized the application, so we don't need to worry on the local installations or all. You have to just make minor changes, not minor even changes. You can just run as it is because the private key names and everything I already changed, and you will just run Docker Compose up and detach mode. So make sure you have to copy crypto configs from here, or you can just provide that path itself directly here. Okay, that is also not required actually. I am just getting that data from directly artifacts itself here. So even this step is also not required. Previously I used to do, but later I changed these things. I'm just picking up from there itself, like this folder itself. If I'm going back, artifact channel crypto config. So you have to just hit Docker compose up and detach mode, so you will be able to run this service. Okay, so moving to the next part, API. So inside the API, so we'll go through the folder structure first, and there are some APIs we have to consider while doing any kind of transactions. So we'll be integrating with that. Okay, let's go to the VS Code now. Okay, you can see on the top there is a dedicated folder API. Inside the API, we have necessary files and folders. Okay, so let's talk about one by one now. Connection profile. Okay, first one is the connection profile. So this connection profile is required to connect from client to the peer. In the transaction flow, when we are talking about this transaction invocation from the API server, right? How this API server know which peer is already, I mean, where he has to send the transactions, right? In his organization, he need to know some kind of peer configuration where he can just send the transaction, and peer will do everything for that purpose. For that, so peer, for knowing this peer information, we are just providing exactly same. This is the localhost 9050. I mean, for this is organization 2 connection profile. For connection profile organization 1, we can see this peer is running on 7051. And we are providing the TLS certificate, because without that we won't be able to communicate with this peer. We are providing this information even for the certificate authority of that organization. Some configuration data we are providing where they can use this TLS certificate and hit that particular domain, and they will be able to communicate with each other. So this connection profile is also getting created while creation of the certificate itself. Let me just show you. In the blockchain, artifacts create certificate with CA and create certificate ca.ss. There is one create connection profile to dial is there. There is a typo, but yeah, just consider this connection profile. We are just going inside that and we are running generate ccp.ss. So there is one shell script actually generate ccp.ss. We are just creating this connection profile. We have template and we are just ingesting some of the relevant information data. Okay, and this file will get created connection argon.json. So when you create a certificate with the certificate authority, it will automatically get created. So don't worry on that. So it's already created. And this is the entry point for the client where they can just connect with the peer and communicate with the peer. All right. So what is the next step? Okay. Other than this connection profile, there are a lot of others. In the SRC, we can see I just made that folder structure controller model services, and it's just straightforward. For user, let me just show you some of the routes. We'll go through it. Okay, authentication, there are different routes. Authentication. So authentication route is for registering and the login, logout, and some test routes are there for testing our API. Okay, registration is nothing but the process where we are just adding the new user, and the flow is admin of that organization will approve that user. I mean, he will make activate or inactivate so that he will be able to log in into the system. So register is just adding the user into our system, but admin of that organization will just approve his request, like making him active. And once his status is active, he will be able to log in into our system. Login is just again the straightforward. We have this validation, some basic validation. After that, we are calling to the control. Let's talk about the login. Okay, in the controller, we have again some logic, like we are getting username and the password. We are just checking auth service login with username and the password. If username and the password is correct or not, we have some kind of logic actually. You guys can just go through this thing. It's a very straightforward, just a basic JavaScript and Node.js code. If user is there and if password is matching, then we are just forwarding user as it is. If it is not, then we have to uh, return the error. Routes, yeah, here. And if user is valid, then we are just creating the token and sending in the form of response. Okay, this is the basic login. Let's talk about the agreement route, which is the main, I would say. In the agreement route, we have different kind of endpoints. ID, okay, so you can see here, gate. This is a get agreement by ID. We are just passing the agreement ID and we'll get the data for that particular ID, agreement data. Next one is the documents. Here we will get the signed URL for the particular. So this AWS, we are storing this data as a confidential, right? It's a private. No one can access it. But for accessing it, we are just creating the signed URL so that that URL will be valid for certain time, maybe 10 minutes, 20 minutes, and it's up to you how to configure it. In the get signed URL, there is a configuration. You can just change and you will be able to get that signed URL will be valid for certain time. Get signed URL. I'm just going inside. Okay. This is the time in seconds. So URL will be valid for 3600 seconds. And after that, you will be won't be able to access that that agreement. Let me just show you. Okay, this agreement, right? You can see. I'm just opening this. You will be able to lend the URL. It will be valid for 3600 second only. This is just a test PDF. But after that, if you're changing anything or something, you won't be able to access this document. And after a certain time, it will get expired, and in that case also, you won't be able to access this document because it's a confidential data for the organization. So we just added the implementation. It's again totally up to you how we wanted to expose this data to particular user or client. But using this URL, anyone can access this like for that particular time before expiry. Okay. Okay, we have another approvals. Okay, when we creating the agreement, we require some additional actions, right? So for that purpose, we have approve agreement, and we will add one approvals for that particular agreement. So for that purpose, we have this route. Next one is the history. If you wanted to check the history, how many transactions we made on that particular agreement, so this is the route for that. And here we have create agreement and get agreements, where we are utilizing on this front end for getting the agreements. Here, this is the list of the agreements, and for this is the create agreement route. Okay. So these are the different. I mean, this is just a basic code. It's not something very big, but we'll go through the creation of the agreement because they're actually uh, we have blockchain call involved. Like whenever we're writing data or getting data from the blockchain, there we have to use some kind of libraries. I wanted to show that. Okay, let's talk about the create agreement. This is again the controller where we are just getting the necessary data. Another one thing, this create agreement, we are passing this data when I'm creating it, right? There is a file as well. So I'm passing everything as a form data. So we for that purpose there is one middleware in the create agreement itself. Let me show you one more time that. Okay, upload file to S3. This is the middleware where if we are having any kind of files, it will just download, it will just upload to the S3 bucket, and it will provide some additional information, metadata. And that metadata we are just getting here. Okay, here metadata. We are just attaching it. Just try to understand and debug the application. Because of the time constraint, I won't be able to go much inside that, but I will try to clear all your concepts. Okay, this file metadata is nothing but the same data which we are providing here. Let me show you that actually what kind of metadata we are storing. Okay, we can see here, right? Document is the array. Sorry, document is the object where we are storing this metadata: content hash, created by, name, org name, updated at, and the URL of that particular file. So this is the metadata. We are just uploading to the S3 bucket, and from there we're forming this object so that later on we can verify it. This metadata again we're passing create agreement, and here I am just creating some kind of object. So ID is the get view ID is one method. I am using nano ID for creation of the randomly generated ID. So you can use anything like UView ID is also there, or maybe let me just check what kind of okay, UID 4 I'm using, sorry, not a nano ID. Maybe somewhere else I used it. But yeah, you can use anything for generation of the random ID. You can create your own implementation as well as per your requirement. Other information is there, type of contract, title, owner, contract ID, department. All this information just I'm putting and creating one object. And this data, okay, here we have a blockchain call. Contract equal to get contract object. So let's try to go inside this. Get contract object. Okay, I'm just going inside. Okay, get contract object is the method where we are doing the blockchain related things. Okay, first of all, whenever any user is trying to invoke the transactions, we need his credentials, right? So for that purpose, we'll be on the organization basis. I'm storing this credentials of that particular user. Let me show you. Okay, wallet is there. Yeah, organization one and organization two. And inside this, we have identities of this organization. Identities public and the private key. Okay, so we are utilizing that. Connection profile is the same what I explained this connection profile where we'll have entry point for the peer, stainless certificate and the peer address actually. Okay, if we are checking identity is not there, then we are throwing error. If identity is there, we are just okay. This is a new steps we have to do because previously we had different implementation and we are now using Fabric Gateway. Okay, Fabric Gateway is the new. Okay, just yeah, this library, connect and signers. Okay, these things we have to use from the Fabric Gateway. Previously, we used to have Fabric Network, but we are not utilizing anywhere. So make sure you are using Fabric Gateway itself. And in the Fabric 2.5, there are some transaction flow changes. So because of that, the flow is little different. Previously, this API itself used to collect all the endorsements and send to the orderer, but now peer will be doing on the behalf of user. So when okay, let me just show you transaction flow here. Okay, previously what happens in Fabric 2.2 or earlier, this client used to send the transaction to the API server. API server used to send this transaction, this in transactions to all the endorsing peer directly, not only one peer. Then every peer will use to get endorse the transaction and send back to the client. Then client used to send directly to the orderer. Okay, but now in the Fabric 2.3 and above, right now we're using 2.5. So client will send transaction to the peer. Peer will be responsible for collecting all the endorsement from the other peer and send back to the orderer. So this responsibility has been moved from API server to the peer itself. And for that purpose, we have to use this Fabric Gateway new library. Okay. Again, I'm just checking here. Uh, client, I'm just creating the get client method I just created here. It's using the TLS certificates and all. You can just go through this, all the functions which are getting used here. Get client is there, connect identity. Get identity is also one more thing. We have to convert into the form of buffer and everything. I mean, this is I already created at the top get identity, get signer. So private key, how we can utilize, and finally create a connection to the gateway. Once we have the connection to the gateway, so we'll be connect to the particular channel. And after that, we have the network. We'll be connect to that particular chain code itself. And once we have this contract object, so we'll be able to invoke the transaction using this contract object. Contract.submit transaction. This is the method which is responsible for sending the transactions. I'm uh, I'm passing two parameters here. First one is the function name. Second one is the actual data. Okay. Function name is I just hard coded here. Create contract. So let's see what exactly this smart contract is doing. Create contract. Okay, let's go to the smart contract itself. Okay, this is just a very basic thing. Create contract. This is the method. I'm just expecting agreement data. Okay, first one is the function name. This is create contract, and second is the actual data. So I'm just passing the data because it will be get sent as the buffer. I'm just parsing it. I will get agreement data. Why I'm passing, I require ID, right, for putting state. And for that purpose, I'm just passing it. I'm just making agreement.id and putting data as it is. So it is storing this for that particular ID. I'm storing all the data. That's why we're able to see on the current state database for that particular key. This is the ID. I'm storing all the data of that particular smart contract. Okay, this one. And that's it. I'm just returning the transaction ID. Okay, I wanted to show what are the different methods available for this context stub. Okay, just a moment. Put state stub. Okay, in the chain code stub, these are the different methods available. You can see here. These are all the methods. It just I mean, it is itself an interface. Get argument, get string, get function and parameter, get transaction ID, get chain code ID. There are a lot of methods. We are using like get state and put state majorly, and some cases some other. But yeah, these are the different methods available. We can see put private data, get private data hash, get private data, purge private data, invoke chain code, set events, get query result. There are a lot of methods. So each having some specific purpose. You can just go through these methods and you will be able to see exactly how it's getting used. I mean, information you will be able to get it. Get transaction by ID in the official documentation or somewhere else. You can just go through all the smart contract method and utilize what your requirement is there. You will just able to say it. You will be able to utilize this method, and every method has some specific purpose. Okay. All right. Let's go to the code now. Okay, this is the smart contract and this is service. We are just putting data, and finally once we are submitting and finally returning the agreement data. Actually inside this data will have all the information. Okay, so this is the all about the creation of any kind of agreement, creation of any kind of data, I would say. And for getting the data as well, I will just show you. Okay, get agreement by ID, right? So the contract object creation would be the exactly same. Here we are getting some ID. I'm just query agreement by ID. Okay, here get contract object, the method is same. The only difference would be we will passing the specific method defined in the smart contract. Get asset by ID is the method and I'm passing the ID. So I'm mentioning like okay, let me just show you get asset by ID. This is the method and this ID we are getting. I'm for that ID. I'm using the same state like get state this method and I'm just passing this data as it is. That is, I mean, that's it. I'm returning the data and we'll be able to see this data for this purpose. And some additional operations we are doing, it totally depends on your use case. When you are talking about the invocation of the transactions from the UI, I will show you these things. But yeah, any question on this part, like creating a transaction or getting a transactions from this new Fabric Gateway library? I think this is the perfect time you can ask the questions on this some specific time, because line by line, it is not possible to go line by line of this code, but still I will try to go through most of the major concept which will require actually.
Yeah, one query. Like if you're using Fabric gateway, so is this connection profile and all needed? Not needed, no?
Yeah, it is required, right? See, okay, that's a very good question. Okay, see, I as a user, I'm sending to the API, right? And API is forming creating a transactions, and this transaction need to send somewhere, right? Somewhere. How this client will know, this API server, where he has to send a transaction? Previously, we used to have a discovery service here, and using uh, okay, there is anchor peer role actually. So this connection profile is the entry point for this transaction to send it here, peer 0. And once the transaction is here, now it's peer responsibility to just discover how many endorsing peers up and running in organization for this transaction, for this chain code and the channel, how many endorsements are required. And that transaction gets sent to relevant endorsing peer using this peer itself right now. But for getting know this peer, we require connection profile where we specify the configuration of the peer. So that's why this API client is required to know connection profile where we define our own peer configuration.
Okay, okay.
You got it right?
Yes, yes, thank you.
Okay.
Hi, Pawan. I have one question on this
Yeah,
endorsement policy.
yes,
I mean,
please.
how this policy is managed in this whole network of blockchain? I mean,
Which
the endorsement policy.
okay, okay. First of all, when you are deploying any kind of chain code, right?
Yeah.
Let me just show you. Yeah, this is also a very good question actually. So I mean, just try to ask question as many. So we'll try to get clarifications on this part. So it's really relevant right now here when you're talking about this transaction invocations and all, and just try to understand the transaction flow. Uh, if you understood the transaction flow, 80% of the fabric you already know. So just make sure you understand it. Okay. So when you are deploying the chain code, right? By default, the chain code policy, if we are not specifying any chain code policy, by default, it would
Mhm.
be the majority. Okay, majority.
Okay.
So in our case, we are explicitly specifying the chain code policy. This is the CC policy. What I'm
Mhm.
mentioning, or of the organization, or of the organization one, org one MSP peer dot either of the organization can endorse the transaction. That is what I'm specifying here. Either
Okay.
organization one peer or organization two peer. One is sufficient for me, and the peer will be managing that like let's consider we have 10 organization and we are specifying either organization one or organization two. So the peer will not send to all the 10 organization, right? He will just send to
That's
any
correct.
one of the two peers and get the endorsement. And if he
Yeah.
is not
Yeah.
getting endorsement on one of the organization, he will send that transaction to one more endorsing peer and try to get sufficient endorsement for fulfilling our chain code policy. So this is the chain code policy where we define for while deploying the chain code itself. If you're not specifying, that is the majority. In our
Oh,
transaction, we can see, let me show you exactly here. Any one of the transaction we can see, endorser is only one organization. It could be organization one or two. We are sending this transaction on the behalf of organization one. And as per the transaction flow, if peer zero organization one itself is a sufficient, it is not sending probably this transaction to other peer because we require only one endorsement. And if you require only one, he is sending, creating the endorsement and sending directly to the orderer. Is that
yeah. It
answer your
is clear.
question?
Yeah. Yeah. It is clear to me. Thank you, Pawan.
Yep.
Hello.
Hey, yeah.
Hello. Good morning, sir. So my
Hey, hi, Nesh. Yeah.
question is that when we commit the chain code, okay, so
Mm-hmm.
it runs as a container, right? The
Mm-hmm.
chain code.
Mm-hmm.
So I was working on it and I faced the issue. So when I was committing the chain code, it was not getting deployed on the same stack where all the services were running. Like if my services are
Okay.
CouchDB
Yeah, yeah. That's
and
yeah. Got
so
your question.
yes, sir. It is getting deployed in another stack. So is there any way I can deploy those two chain codes if I'm using two organization? So if we can deploy those chain code in that stack where all the services are running. So this is my question. So if you could help me out.
Okay, okay, yeah, definitely. Okay, so did you try to approach community or someone else to identify the issue? Someone help you on that?
No, I didn't ask. I was waiting for this webinar only to ask you this question
Oh
because
man, you could have connected me on the LinkedIn. You could have saved a lot of time. I mean, I see. I have gone through all these issues actually earlier. It is very tough to get these kind of resources. You will not get actually. I mean, maybe you will get right now. I'm not sure, but when I used to practice these things, right, it was very tough to get those kind of issues. So we have to go inside and try to understand why. I mean, this the Docker networking is also very important to understand this concept. Okay, so the chain code container is not getting created within the same container because of in the peer configuration you have to specify it. Let me just show you artifacts docker compose.yaml file. This is the file, right, where we have the peer configuration. Let me just go through one of the peer configuration. You will be able to see core VM docker host config network mode. here we are specifying container will get created inside this network and they will be able to communicate with each other.
Okay, so sir, can you go like at the top of this compose file, sir?
Yes, please. Yeah.
So over here we are in the network section, we are mentioning the network as test. But
Mhm.
in that the peer configuration, we have mentioned the network like as an artifacts dot underscore test. So
Okay,
we
okay.
can, yes, sir.
What happens whenever we are not providing a Docker Compose project name? So by default, that folder will get assigned for that network. Artifact underscore test. Test is the network under the artifacts. If you wanted to explicitly provide, you can do it. That's totally up to you. But if you're not providing anything, it will just consider this folder name as the initial of that particular network name. Artifact underscore test. And here, while creating this Explorer container, you can see here, right? I have name of the folder is Explorer, but I'm explicitly specifying compose project name. Just consider this as an artifact. This is the environment variable we require for running this container service, and it will consider as a network name artifact underscore test, and test is I specified inside this Docker compose file name itself.
Okay, okay, sir. So
You
is
got it
there
right?
any way you can help me visualize it, like how that chain code container is getting committed in the same stack? If you have any like tool like Docker desktop and all, if you could show it over there, then it would be really helpful for me.
Okay, yeah, I can share show from here itself. I do not have Docker desktop installed on my Ubuntu machine, but I will just try to show you here. Just a moment.
Okay, sir.
Okay, so we can just check Docker network ls. It will just give the list of the network you have. Okay, and within any kind of network, you can just check how many containers are there. So mainly we are dealing with the artifact underscore test. So our container is also getting created. I will show you here. Docker inspect network name. We can see here, right? This is the container which is available inside the same network.
Okay, okay. Got it, sir. Got it, sir. Thank you so much.
Here also we have the same.
Yes.
Two containers are there, so we'll having two chain code containers. And this is a really good question. I've been see you will go through this phase actually. I'm sure every developer will, because if they're making some small mistake, I would say like just try to connect with any community member or someone who already know. You can save a lot of your time. I know your potential. You will be able to identify that issue, but uh, it will just take some time. There will be a learning curve, of course, but instead of that, maybe initially if you are trying to connect, would be helpful for yourself as well.
Okay, sir. Thank you so much.
Hello. Hello, sir.
Yeah.
Yes, sir. I had this one doubt related to channel creation.
Mhm.
I am done with creating the channel transaction file, but are we also required to create order.yml or code.yml files before creating the channel? Because I'm facing
No,
some issues in creating the channel. Something deadline extended error is coming.
no, I mean those are not required actually.
Okay.
Say by default it comes with the core configuration files for the peer and the orderers. So while creating the channel, let me just show you scripts. We require only these important things: core, peer, a local MSP path, root TLS certificate. Did you try with this repository or you have your own?
I have my own repository, but I have defined all these variables. So still the
Okay.
error is coming.
We need to check actually what is the misconfiguration if it is there.
All right.
Okay, one more thing. Okay, yeah, probably this could be the issue. Core fabric config path. This we have to provide actually, and this is the path of the core.yml file. which is available inside this. I already have that. You have to export this as well. If the issue is related to that particular code.yaml, so you will be able to solve using this. This export we have to do it.
Okay. I'll check on this. I think I already have this part defined where my core file is available.
Yeah, I mean, see, I have shared all the resources for this, so you can just try to replicate these things. And if you want everything, I mean, this recording also anyway, Ravi is going to share. But still, if you wanted to have a very granular level of understanding and all, I mean, the same course I already published. Maybe you can just refer that as well. It's kind of paid, but I will provide the coupons and all if you require. But all the resources I already shared. It's totally free on the our this specific page. Actually, Ravi has already shared.
All right, sir. Thank you so
Yeah.
much.
Any other question?
There is a question from AM on the chat, last chat comment.
Okay, got it. If I have a function that needs to include in my smart contract and it's a computationally expensive, it may lead to increase in latency and make network. Okay. So if it is required, then we can't move to the API layer, right? API layer, some organization um, is holding it actually, right? So if three organizations are there, there is a possibility all three network have different API itself and their different logic. But smart contract will be their main entry point to data, right? So every smart contract will compute um, whatever the business logic you have. I mean, it's fine if you have even though expensive computational. If it is required for the business use case, then definitely um, we have to have that at the smart contract layer itself. One more important thing, if you have some kind of computation which is just creating the random data at the smart contract, it was always recommended to have those kind of calculation at the API side, because let's consider I'm creating a random UUID at the smart contract and I require two endorsement from two organization. So in that case, one organization will create a separate different UUID, other organization will create a separate UUID, and their response will not match and the transaction will never get executed successfully. It will have endorsement failure. Okay, that's a different thing. But yeah, if it is required to have that logic at the smart contract, then it's better to have at the smart contract only. But if you can skip it and move to the API layer, it would be good actually, if it is possible. Is that answer your question? You can unmute yourself and you can ask. Okay, cool. Any other question? Okay, all right, let's move then. We have a lot of methods actually. Let me just show you the again agenda. Okay, so this JWT verifications and all, I am not going to cover in much depth. I mean, I'm just going through the flow, but not how JWT works and all. These are the basic concept, right? Another one thing, for the API server, I'm using a MongoDB, right? Why I'm using MongoDB? For storing the username and the password, because from the front end, we are not giving this public key, private key, and the certificate to the user. These users, I mean, right now the users are not mature enough to handle this public key, the private key. If they lose that, then there should be a problem. So for that purpose, we are storing this wallet identities at the wallet at the API side itself. We are just allowing them to use the username and the password for interacting with the network. And storing that username and the password, we are using the MongoDB as a database. And you need to have that MongoDB and S3 bucket configured. And for that purpose, starting this API server itself, we require this environmental variable file. Okay, so this is the random data you have to add actually. Not random data, but relevant data. MongoDB username and the password is AWS. Amazon Web Services access key, secret, private key, this bucket name we require actually. Majorly this MongoDB related and the AWS related information we require. So you will be able to access this S3 for VSW3. Sorry, AWS for the S3 and the MongoDB for the storing this credentials. Okay, these two things are required. So make sure you already have that. This is just a free actually. You can create a network. Sorry, you can create a AWS account. So for 1 year, it's free up to certain limit. You can utilize that actually. Okay. And for starting this server, we require these things. In the .env.sample file, I already provided the sample things. You have to just append this data in front of this. Okay. So, okay, invocation of the transactions, uploading file to S3 bucket. Again, we have gone through the basic API side, querying the transactions, updating the transactions. Anyway, we'll go through these all the API again when we're talking about the UI, React UI in the next session, how we're interacting, how we're sending the data and all. One more important thing, there are some certain system chain codes. What are the system chain codes? Say, whatever we are deploying, those are the user defined chain code. The smart contract chain code we deployed, right, for the invocation of the agreement, getting the agreement, approving the agreement. This is the user defined chain code, but there are certain system chain code as well. Let me just show you purpose of all of them. Okay, system chain codes are inbuilt and defined inside the this framework itself. First one is the lifecycle system chain code. Second one is the ESCC endorsement system chain code. Third one is the VSCC validation system chain code. Fourth is the CSCC, that is the configuration system chain code. And finally is the query system chain code. Okay. LFCC is used for lifecycle system chain code. When we are deploying any kind of smart contract, right, it goes to certain state of steps. First one, we have to create the package, install it. We have to get the approvals. That all the things covered by this LFCC, lifecycle system chain code. Next one is the endorsement system chain code. Endorsement system chain code, when we are sending any transactions, right, to the one of the peer, this peer is sending this transaction to all the endorsing peer. So here endorsing peer will do this kind of computation and they will just validate the transactions, and this chain code is responsible for doing this all the things. ESCC is the endorsement system chain code. When client send transaction to the particular endorsing peer, the signed proposal will get first validated, created a read set and a write set, right? I was showing this read set and write set in transactions. This will get created using this chain code itself, endorsement system chain code. Okay. Next one is the validation system chain code. When the transaction gets sent to orderer create a block and send this block to all the leader peer. Leader peer again send this block to all the peer, right? And finally they have the block. They will just decode the transaction. Sorry, they will decode this block and decode all the transaction inside the block. And again, one more validation happens. That is the validation system chain code. They will just decode one by one transaction, validate if this transaction had sufficient endorsements or not. Each endorsement is right or not. Read set and write set are correct. So this validation happens, and this is the chain code is responsible for doing this all the thing. MVCC, this is not the chain code actually. This is a multi-version concurrency control where we are creating the transaction and putting into the block, right? So this we orderer. If you are doing two transactions on one same key, so there we have this MVCC, multi-version concurrency control, and it will just validated how you are implementing your smart contract. So let's consider same agreement. You have made two transactions. First one you are updating, sorry, adding. Second one you are updating. This version control I mentioned, right? In the current state database, we will maintain one version here. Revision is the things actually. This is the version. First thing is the version actually we are maintaining, and there this MUCC plays vital role for committing the transaction or rejecting the transaction. Sometimes you may face this MUCC conflicts error. So because of that only we may face this. Next one is the configuration system chain code. So if you wanted to make some kind of configuration changes, like if you wanted to add one more organization, if you wanted to remove one organization, add organization, or add orders, so this kind of operation, this chain code is responsible for that. And finally, query system chain code. If we wanted to get block by block number or transaction by transaction ID, get chain code information or block by transaction ID, these all the methods are exported inside this chain code. We'll be utilizing this chain code as well here in our application, and it gives the like block by block number or transaction by transaction ID. Okay, these are the different things actually in the okay here. Okay, system chain code we have gone through, like these are the basic, I mean important things to understand, like what is the purpose of each system chain codes and all. QSCC, as I already mentioned, this is the query system chain code. We will be utilizing this in our API server itself for getting the transaction by transaction ID or block by block number. Next one is attribute based access control. Okay, so this part will cover actually in the next session from UI when we are interacting with the network, right? But I will just give a brief on this. Attribute based access control, it means we will define some sort of attributes in our chain code, sorry, in our certificate of the user itself. Let me just show you. We'll just go through one of the user certificate. We just created this one, right? Beacon certificate. Okay, this is the certificate of that user. We'll just decode this certificate now. All right, we can see here, right? In this certificate, we have added this attributes. Department equal to, I mean, it's empty right now, but role is the approver. So we can define this kind of attributes inside the certificate itself while registering an enrollment, and we can validate this row. I mean, these are different attributes at the smart contract layer. Let me show you. There is a one method in our smart contract. I'm just checking. So let's consider you have some kind of restrictions, like organization one should be able to create the contract, organization two should just get an error. So that kind of restrictions we can just add inside the chain code itself. Let me just show you. Okay, attribute based access control. It's having, I mean, one identity is there, client and identity. We can just get different kind of attributes. This is the attribute, get ID, get ID bytes, get MSP ID. We can get a lot of other information as well. But let's consider, I am saying if only financial department have authority to create the transactions. Other than that, no one can create the create some kind of context, right? If I'm just checking this CID, this is the client identity. I'm just checking if this user has department as the attribute and its value is the financial, then only allow them to create the agreement. If they are not a part of financial department, or we are just throwing an error, you are not authorized to perform this operation. Only financial department user can do this operation. It's totally up to you how you wanted to implement your business logic, but this kind of restrictions you can add in the smart contract as well. Like this user should have this attribute and this value should be this one. Then only he is allowed to do this kind of operations. Did you get any? Sorry, did you get the concept of the attribute based access control? Or you can ask questions on this part, because these are the core concept and very important to understand the hyperledger fabric, the system chain code, QSAC, ABAC. This is attribute based access control. Any question on this? Okay, access control list I will explain in the next session. Upgrading the chain code. Now, previously we had only one, sorry, we have deployed our smart contract, right? So the default policy was OR at the top, we can see here. If you wanted to make changes like OR to AND, so we have to make one more upgrade. Upgrading the chain code policy, this is the script I have already written. And here we have the chain code policy, and both of the organization need to endorse the transaction. This we are defining. So we require one more deployment for the smart contract. So we have, okay, another one thing you can see version and the sequence. Why two things are there? If you wanted to make any chain code policy changes, then we require only sequence to be bumped up, like from 1 to 2, 2 to 3, something like that. But if you have code changes in the smart contract, like you introduce one more method in the smart contract, the code is getting changed, right? So in that case, you have to change the version as well. So you have to understand when to change the version and when to use the sequence. So I'm just changing the chain code policy. I'm just making the sequence change. And for that purpose, we just require to approve the chain code. We don't require to install, because installation of the chain code is required only when if we have changed the code in the chain code. The chain code is exactly same, only this chain code policy we are just changing, right? So for that purpose, we require just approval from the both of the organization, and that's it. We will be able to commit the chain code with the updated chain code policy. And next time, if you are doing this chain code invocation, we require both of the approvals, and it will get added automatically as per our chain code policy. Okay, data persistency is one of the most important concept actually. Okay, so in the docker compose.yaml file, you could see here, there is a commented line here. Right now, if I'm doing docker compose down, all our network will get destroyed, and whatever the data we have, we will lose that data. But why we have started with that? This is not the way, right? In the production network, we should always have the persistent. So why I added, why I have commented this code? I mean, it was just kind of deliberate. I wanted to make you do this operation again and again, like 10 to 15 times. So you will get used to this, like creation of the network again and again, and you will get familiar with this different kind of steps. But when we are dealing with the actual network, right, we should always have this line. We are persisting the data /var /hyperledger /production. Inside the container, we have this folder where we are storing actually production data. Let me just show you that as well. Docker exec-it peer0org1 example.com assets. Okay, I'm going inside the container peer0 organization one. Okay, currently I'm inside this peer actually. So I'm just going cd /var /hyperledger /production, and we can see all the data is getting stored inside this folder: chain code, external builder, ledger data, lifecycle, snapshot, transient store, file lock, transient store, everything is getting stored inside this. Let me show you how exactly ledger look like. Inside, sorry. Okay, this is the block file. Say inside the blocks file, we have all the blocks right now. I mean, up to 64 MB, one block file will get created. If it is exceeding, one more block file will get created. It will just create one more file here. So let me show you how this block file looks like. It is just a protobuf format, I think. I'm just opening it. You can see the data right inside this. Whatever data we created, you will be able to see, but this little different format. But certificates and all will be able to see it. This is the agreement data, type of approval. Lot of things are there actually. So you can just decode this data and just check what exactly it's having. We can see this key value information is already there inside this. Okay, this is the block file actually inside the Hyperledger Fabric. So for that purpose, we have to persist this data. So in the next session, what we will do, we'll just create the network with persisted data, and we will be able to recover that, like last point. Even though this network goes down, still we'll be able to manage from the last point of failure. Whatever the transaction we had, those will be always there. So this will persist the data. So without, I mean, for the production, we should always have this kind of things. Otherwise, if some machine goes down or something, it will create a problem. So for that, we require to persist this data on machine, and it will be always there And you don't need to create the channel and the chain deployment of the chain code again and again. If you have persisted the data, you can just invoke the transactions. That's it. Any question on this persistent? Now we can take some questions like, I mean, random question, that should be fine. But yeah, these were all about the API chain code. Any question?
Hello.
Yeah, Nick. Yeah.
Sir, there's a question which there's actually an issue which I was facing. So I was like kind of deploying these things on the cloud. Okay, and I was using the Docker Swarm for it, like the Docker Swarm concept. So I was using GCP platform. So like everything worked fine. So what I did is that since it was costing me money, so I created like three virtual machines, and on each virtual machine, I connected through the Docker Swarm. And after I like closed my virtual machines and then restarted it, so the IP address changed. So now the mapping which I had done in the DNS configuration file in the etc host file, so it is creating problem over there because the IP address has changed and I should change the DNS configuration file. So it is becoming like quite manual for me. Is there any way I can automate these things?
Uh, okay, so first thing, if you have some dependency on the IP addresses, you should always opt in for the static IPs. Even though your machine goes down, the IP would be always with you. And if you're creating the machine, so you will have flexibility to have the same IP. But it will cost you additional actually for getting the static IP. But this process you can just make it like when your machine is getting started with the same IP, I mean newly created IP, probably you can make some kind of script where it will do the same steps which we followed last time.
Okay. So will it be a good practice to do it like using static IP?
Static IP, it means, see, you are saying GCP, this is the IP I am going to own. Do not allocate to anyone. And you are utilizing it, right? It should not be a problem. Docker Swarm network always require that
Okay. Okay. Got
because
it,
the
sir.
connection
Thank
is happening with these IP addresses, right?
you. Yes. Yes.
Yeah.
Thank you, sir.
Any other question? Guys, any question?
And there is a message response. Actually, if you are using Oracle Cloud, it gives two free VMS with static IPs. So that may help the person who asked the question.
Okay, okay. Yeah, yeah. On Oracle it provides, right? So I'm not sure. But yeah, that's a good thing then if you have to VM static IP without any charge. Yeah, that's a good. Any other question? By the way, I mean, see, everything I provided you, resources and everything. Anyway, what I mean, any doubt also, you will always welcome to ask me. But still, if you guys are interested, there is a bootcamp we are going to start, me and my friend Aditya. So if you guys are interested, you can just, we'll try to cover Hyperledger Fabric. This bootcamp intensively is focusing on the actual internal working of the Hyperledger Fabric. So it will be 8 week of webinar. It's having almost 25 to 30 hours. So if you guys are interested, you can just check if it is relevant for you. I'll be sharing the link if you guys are interested. Any other question? It's a online. I mean, it's a live actually. It's not recorded. And same course actually I published as well. It's almost 12 hours of course. If you guys are interested, that also you can just check if it is if you require more in-depth things actually for that. But yeah, for asking questions and all, you can always connect with me even on the same POC, because I have already given all the resources, codes and everything. You can just run these as well and get all the internal things, how it's working. Any question? I think we are running out of time. We'll take last two question if you have anyone. Okay, Ravi, I think we are good to close today's session. We have covered both of the topic today. The first one was the blockchain explorer. Second one is the actual API. Because of the time constraint, I'm taking little faster, but just I'm sure you are already familiar with the JavaScripts and all. So you can just go through the code and try to understand each and everything. Because I created this POC just for understanding the concept. It's not something production grade. I mean, it's not something some specific use case I covered. So for each concept, and I try to cover one specific section or some endpoints I exposed it. You can just add, update, or do anything with this POC code, and you can just create your own. You can utilize the code as well. I just try to follow from the backend side. I just sort of followed the folder structures and everything very well. So you can just utilize it. Maybe you can just create better than this, I'm sure. But still you can refer the code how we implemented. Because on the Hyperledger Fabric 2.5, probably you will not find. I'm not sure, but I tried. I did not find. I just created this course to covering the 2.5 aspects of the Hyperledger Fabric. It's totally new, and you will get a references on the Fabric samples. But this kind of things at the one place you will not get. I'm sure on that right now. Ravi, I think yeah, we are good to close today's session.
Okay, so if there are questions, you can ask even last one or two questions. If
Yeah,
not,
yeah.
okay, I believe that's all. So thank you, Pavan, for your wonderful session, and we will meet next week. Means what would be the date? 17th.
The 17th.
17th at 10 to 12. Okay. So thank you,
Yeah,
everybody,
Ravi,
and see you next week.
I will add one point. So if anyone is interested in setting up student chapter in your institutions, feel free to write to us. hyperledger.india.chapter@gmail.com. We will respond to that, and you can see the details in our wiki page also. But we are happy to help you. It is like we want to serve the student community and make them industry ready. That is our motto. So see you all. Thank you, everyone.
Yep. Thank you, guys. Have a great day.
Thank you. And anyways, if anybody is interested for Hyperledger mentorship, so at 12 means in just 25 minutes, we will have a LinkedIn live session about Hyperledger mentorship, and you are welcome to join for any questions, discussion, or anything. Thank you.
Yep. Thank you, guys.
Thank you, everyone.